So our final talk before lunch, we're going to move now into focusing on the different countries. And Siim Nirgi from the Geological Survey of Estonia, is going to tell us about reinvestigating the historic drill cores here in Estonia to understand the potential for critical raw materials in Estonia's crystalline basement. All yours.
So hello everyone. First of all, a huge thanks to Eric for giving the best introduction or background to my talk. And also another big thanks for leaving Estonian area gray, because otherwise I would have nothing to talk about. Okay, so this is the headline of my talk. I'm working with the crystalline basement of Estonia, and I'm going to give some insights what we have been doing and about some of the results of our latest project, which was about looking the historical drill cores. Now I'm going to take off where Eric stopped at some point. Estonian crystalline basement. Of course, we are on the East European platform, but underneath the sedimentary rocks, we also have the Fennoscandian, let's say, shield or crystalline rocks. Different geologists have studied it during, I would say, decades, and using the lead dating, they have seen that the Estonian crystalline rocks can be correlated with ones in Bergslagen, for example, or southern Finland. So a few examples there. Now, if we are talking about the exploration in the crystalline basement, this is greenfield, which means it's challenging, like Eric said. And challenging because it is all buried, there are no outcrops, and the only way to explore something in there is by drilling it or doing geophysics. Now, the geologists have not been sitting, doing nothing for almost 100 years. They have investigated crystalline rocks quite a lot in Estonia with the main purpose to find something. So this started around 1930s with the first project. And on these drawings, you can see that the crystalline basement is dipping in Estonia. So we have around 150, 200 meters of overburden in northern Estonia and up to 700 or 800 meters in the southern Estonia. Altogether, there's around 500 drill holes drilled in the crystalline rocks during the history. And using the geophysics, the airborne magnetics and gravimetry, also data from the drill holes, these crystalline rock maps have been drawn. Luckily, I would say it is very, let's say, detailed. But if you look the placement of the drill holes, the reliability of the map in northern part is a lot higher than in the southern part of Estonia. And actually you can see that there might be a lot of fantasy in there, and it might not be that reliable actually, if you look at it this way. During these studies or investigations, most of the rock material is fortunately preserved. Unfortunately, a lot of samples and sample archives have been destroyed, so we are not able to just take the old sample duplicates and analyze them again with new methods, but still we can look at the drill cores and analyze the drill cores and take new samples if we need to. So if we look at the results of the historical investigations, well, mainly these were done during the deep mapping projects in 60s, 70s, and 80s. They took a lot of samples. More than 20,000 analyses have been done from crystalline rocks. There are more than 10,000 thin sections available to study, so there's a lot of material. There's lots of reports as well, most of in Russian, but still very valuable material. Now if we look at the mineral occurrence map, so we don't have any economic deposits in the crystalline rocks of Estonia. But can someone guess why is that? Just a guess why there are no economic deposits. That's the first thing. We haven't found anything, let's say. Yeah. Well, maybe we haven't found anything because we haven't looked the right things, for example. The studies in 60s and 70s focused mainly on the base metals. So no one really cared about lithium or rare earths. Firstly, because there was no demand for these elements. And secondly, they are too often in so small concentrations that they didn't even analyze them because there was no capability for doing this. Another case might be that they looked they didn't look close enough. So actually they drilled some indications, but they didn't look close enough because the sampling, let's say, standards back then in Estonia was that they took pick samples from 1 meter, just few picks, then made a composite sample and then analyzed it. So if there was something in between, let's say a 20 centimeter vein of something interesting, they might have missed it. And the third case can be that there is actually nothing, but we hope not. So what should Geological Survey do with this data? So our task regarding the crystalline rocks would be to study or investigate, try to find something until someone else, let's say private sector, finds it attractive to start taking over. So this, I would say, is our purpose of our work. And for this, we have drawn a framework. So last year, we published a roadmap for exploring or studying or investigating the crystalline rocks in order to find something, let's say critical raw materials. So in a sense, it is a framework for the national program for the Critical Raw Material Act, I would say. It just doesn't have it is the context, but it doesn't have the information in there. So in regarding to this scheme, we have digitalized a lot of historical data, like Sirli showed. We have organized drill core archive, what you will see on Wednesday. We have analyzed, I would say, not thoroughly enough yet, but still analyzed the historical data. And now the next step would be to look these historical drill cores more closer than it was done in the 70s. And in the end, hopefully, we can find some indications that are worth drilling, doing detailed geophysics, and so on. So this is a framework. A few years ago, we had a project in northeastern Estonia, in Jõhvi, for investigating a magnetic anomaly. So in there, we knew that we are not going to find any world-class iron ore deposit because there's no point in looking at it. But we were hoping to find some sulfide mineralization in there, and the historical drill cores were not preserved. So in this project, we already had all the preliminary work done, and we could go straight to the exploration program and do drilling. But at the moment where we have 3,000 boxes of crystalline rocks in the archive, we really don't know where to start from. So we have to look these old drill cores closer. So this is why. Now, about what are we looking for? So this is based on the Nordic Innovation Report published in 2021, I think. We just took the explanations for different raw materials and in which kind of environments they exist in the Nordic countries or in the other parts of the Fennoscandian Shield. And then we put them in the Estonian context. What kind of rocks, structural blocks where we have, and this is the list. So I would add a few other things in there. Well, not all of these are critical raw materials, but these are the ones that might be worth looking for, because we have 300 meters of overburden, so it can't be iron ore that we are looking because it has to be something more worth. Now more about the project that we did. So we reinvestigated the historical drill cores using, let's say, it's automated workstation. It's not scanner per se because it doesn't do continuous scan. but it does point measurements, but still it can do a lot more than human hand and human eye. So on this device, we have the XRF, we have the spectrometer, so ASD lab spec, and then we have the magnetic susceptibility sensor, and of course the high-spec camera for documenting all the things that the machine sees. You are going to see this on Wednesday as well, so I'm going to give a little talk in there as well. Now, this is the method, and now the question is what to look like. We have 3,000 boxes. So we use the historical geochemical analysis results for picking out the most promising or more, let's say, potential drill cores. And funny or not, they all happen to be in one cluster. And now we have produced for the GCU, we have produced the copper metallogenic map layer as well. And we can see on the historical data that the copper metallogenic area kind of overlaps with it. So if anyone wants to explore anything in Estonia, this would be the area to look for. And on the right side, you can see the different rock types that are related with the high concentration of elements, well, based on the historical data. Now, what did we look from the new data that we collected? So for different critical raw materials, you really can't analyze the concentration because of the XRF limitations, for example. So you have to look the associations. So different, well, this is the compatibility of elements, basically. We looked different kinds of, and basically what we did, we look for correlations and the high, not concentration, but where we got the high counts. So lots of high intensities of elements for XRFs, and then we looked at correlations between these. Important thing, what I want to show with this table is that the measurements per meter, it was between, let's say, 3 to 10 measurements per meter. So this is a lot more denser analysis density or sampling density than what was done with the historical analysis. So we looked a lot closer. Now, yeah, just an example for nickel, cobalt, and chromium. So of course, they're compatible elements. We can see a nice correlation, but we looked only for the higher intensities. So basically, we picked out the right top side and then isolated these intervals in the drill cores. Most often we can see, let's say, nickel, cobalt, chromium is the easiest because it goes well together with mafic and ultramafic rocks. So in this case, we have the peridotites, and of course, we can see the high correlations and high intensities in these intervals. But with different associations, we started seeing a lot of very interesting things, that the high concentrations or high intensities don't have to go together with certain rock types. So they, let's say the arsenic, stibbium, bismuth, tungsten, selenium, this association, you could see it in various rock types that was described historically. Well, this means that it must be a secondary mineralization, or it could be secondary mineralization related with hydrothermal processes, for example. So this is, that's not been studied yet, and it has to, let's say, take off from this point. Now, what we produced with this study, we produced for every association let's say the isolated intervals, where to go next, where to do more detailed study, and look for these, let's say, anomalies. Now, the goal of this project, I should have put this as a first slide, but it was to detect the prospective CRM occurrences in the crystalline basement of northeastern Estonia. We didn't actually stick with northeastern because we used the historical data to define the most promising area. And then our goal was to collect comprehensive data from historical drill cores and make it available to use for applied and academical purposes. So all the data, the raw data as well, we're going to publish it online. So everyone who has an interest, wants to double check the results or go further from there, can use this data. And it's not only the numbers, it's the spectrum files, the raw photos, everything. So this was the biggest, let's say, goal. But fortunately, we detected the anomalies as well. So it was not only that we measured and published something, but I think we defined around 150 intervals of interest, where to go back, take a sample, and go further. So the conclusion was that the historical drill cores appeared to be more heterogeneous. This is quite a logical thing because historically these drill cores were described macroscopically. So with this sampling density, you can see a lot of more changes in the geochemistry, but also in the mineralogy as well. Then quite a simple conclusion, but the copper, nickel, and cobalt, chromium associations were found mainly in mafic and ultramafic rocks. Quite logical, actually. Well, in the Estonian case, I would say these are potential in this sense, but we know where we have these ultramafic intrusions, and they are not that big, actually. So it might be like the best thing, I would say. But all the other element associations, like I said, they can occur in variable rock units, in graphite schists, in biotite gneisses, in granite rocks. So who knows what are these linked to, but this needs like further studies, as I said. So the next steps would be, well, one of the goals was also to try to map the potential areas. It is very difficult to do it with single drill core data. You can get just point data on the map. But where we saw some indications, we could also investigate the neighboring drill cores. So maybe we can see some clustering somewhere. And also the results of these data. This is like express method. We only analyze the surface of historical drill core. So there can be various things that can affect the results, the possible contamination and so on. So basically all these indicated or defined intervals should be studied with more precise methods, actually. And then the next step would be to look what kind of mineral phases are these anomalies connected with, and try to describe the mineralization model. So at the moment, we don't really have a good idea. We know, yes, mafic, ultramafic rocks. We have nickel, cobalt, chromium in there, but all the other elements, we really have no clue. Yeah. And also, the final conclusion would be that we should put all the new important material that we are drilling into the machine, because the data that we get from there is a lot more comprehensive that you can get with just microscopic description or even handheld XRF. So you can automate the human work, which is a good thing. So thank you.
Thank you very much. And I'm going to take the privilege of being here to ask the first question. So when you have drill cores at a relatively low density, your chance of actually hitting any critical raw material deposit, of course, would be quite low. And as Eric showed us, that means that you need to understand the geological setting better to understand where you might find different types of deposits, which is really difficult when you can't see the rocks. But one of the key data sets to understand that is geochronology, to be able to place the rocks that you have in the setting that we understand from the countries around. And I'm wondering, do you have access to be able to date your samples Or is that something that's missing and something that maybe Estonia needs more support on?
Yeah, that's a good question. So we are not doing enough datings. I'm quite sure of that. There is we know the framework, we know the general age of the rocks, and we know that majority of the metamorphic rocks are, well, in certain regions are in certain age. Some of the structural blocks, what we have on the maps, we have the blocks. Some of these have only few datings. So it's not actually that reliable. I mean, even in 1980s, I think until that period, we or geologists thought that the southern Estonia is of Archean age. So, and someone dated the South Estonian rocks, and so no, these are even younger than the northern Estonian rocks. So yeah, dating would be quite beneficial. Yeah, definitely.
Interesting, thank you. Any more questions? Eric.
Are we on? Yes. Thanks for an interesting talk and thanks for the kind comments. I'm thinking about rare earth elements, of course, always do. And you mentioned that among the sort of classifications that you had on one of the initial slides, particular perhaps associated with pegmatites.
Oh yeah. We look the association that's like, let's say, common for pegmatites. Yeah.
But as I do think that most agree on the fact that we have parts of the so-called Trans-Scandinavian igneous belt rocks continuing under the Baltic and into at least part of Estonia.
No, I don't think so.
Not really. So I kind of glimpsed it on if you can get that map back up again, if it's possible. Someone back there?
I think no. Can you put my slides on? Thank you.
Of course they can. What I was going to drive at anyway was the fact that we now know a lot more of, there we go, of.
So it was this one?
No, it was the actual rock types. Do we have the correlation between the Paleoproterozoic of Sweden and Finland with that of Estonia?
So you actually meant the first slide.
Yeah, this is it. So we basically see that we have perhaps a touch of those rocks there, but otherwise we are much further down to the south in order to have those TIB rocks. Okay, I thought it was actually a bigger proportion. As you hear, I'm no expert on the continuation below the Baltic Sea, and that's also one good point why I left it all gray.
Yeah, we have to put it together.
Because we have this new data on the Ulcerum type mineralizations, and just last week I got some news that the regional albite alteration that we seem to be able to connect with that kind of rare earth element deposits seems to be much more widespread than anyone had ever guessed. And that would be sort of a marker to look for even in scattered holes, I would say. So, yeah.
Yeah, thank you.
Am I right in thinking that this map it's almost a hypothesis to test still, that the connection from Finland and Sweden to Estonia in terms of the basement geology is still not very well understood, or do you think we know it well?
Well, so this is based on the datings and well, the general rock types, but still we can't see the same things as in Bergslagen in Estonia, or we haven't seen. So yeah, this is a wild guess, I would say. What would help would be the Fennoscan and Shield mapping on the marine areas, and that would actually help. There's a map sheet from 1996, I think, where the Estonia, south of Finland, and part of Sweden was all drawn together. And this was based on the geophysics mainly. Well, but I guess it's possible to also sample some places. Yeah, it's not that deep. Yeah.
There's a question here.
My question is that did you find some correlation between this fault system boundaries of different structures and mineralization, for example?
So you mean near the structural blocks? Well, actually, we didn't look at it in this way. We could look at it this way, but we don't even know where the actual boundaries are. So this is quite a difficult thing. So a lot of drill cores that we studied are from the old mapping profiles. So the Asamala profile, the Hailala profile, which were not specifically done for mapping purpose, but for mineral exploration purpose, because there was a geophysical anomaly that was studied. And these drill cores, thanks to the magnetic anomaly also, appeared to be potential for scanning. But yeah, these were not across the boundaries. So what we should do is, to look if we have the more indications or more anomalies near the boundaries, because near the boundaries we have the contact zones of different rock types, a possible place for mineralization, of course. Yep.
Are there any more questions? Eric again? Oh, sorry. Okay, so one at the back first, and then we'll go to Eric. Go on.
Okay, can I speak now? Yeah. So just to complement, my name is Juan. I have been investigating the Precambrian basement of Estonia. So like an introduction, I invite you to see my poster because it's about how Alutaguse is related to the southern part. I compare samples from metavolcanics and metasediments from Alutaguse with Uusimaa, Häme, and the south belt of Finland. And indeed, you can find a certain correlation that suggests somehow that in Alutaguse maybe they occur VMS, similar to the one that you may find in Bergslagen. So it may be more associated with Uusimaa rather than the other ones. So yeah, just want to remark that there's a correlation nowadays. And well, I invite you to see my poster. And it's part of the new exploration project that we start with Horizon project actually. So yeah, I just want to compliment you in that sense that there's like some kind of research undergoing.
Yeah. Just a small comment on this as well. So in the list of the associated elements, there was no lead, copper, like the typical VMS association. So we are going to add it in the report as well. So at the moment we didn't have it. We had to review and we are going to modify it a little bit. So we are going to look for the VMS as well. So yeah.
Well, just a technical question really. Maybe you mentioned something about this and I missed it, but do you have access to at least a proportion of the original holes?
Sorry?
Holes, are they preserved? Are they capped?
You mean the
or
drill
are they
holes?
all gone?
You mean the drill holes?
The actual holes?
Unfortunately, no.
Okay.
No. So yeah.
Yeah, I mean, I was guessing that would be the case perhaps, but it's really, really sad because otherwise, I mean, you had the options of downhole methods and whatnot. So,
yeah.
Okay.
Yeah.
Thanks.
We're going to wrap up for lunch now, but I think I could probably summarize that as saying the Estonian basement has a very few pinpricks in it compared with its scale, and there could be a lot there to understand. So collaboration with the Geological Survey of Estonia remains very important